So, hi guys, how are you all? I hope all of you are doing good. Young risers, I have started just now 3:30 exactly. I'm on time. So, how are you? And I just want all of you guys to write your names and where are you from. First of all, let us know each other, and then we'll start. And first of all, I just want to ask you, how is the quality of the broadcast? That is, if you can see me properly and you can hear me properly as well, right? So you can write in the chat, and I'll be moving ahead after knowing that if you can rate it from 1 to 10, that is if you can hear me properly and if you can see me properly, right? So you can rate it, that is 1 for the worst and 10 for the best. Okay, so you can write down in the chat that where are you from, what is your real name. And Anish, we have started. Hello, hi. Okay, so we'll be moving ahead. And first, as all of you know, that I just want to ask you, how is your preparation going on for the exam, right? How are you preparing really, really well? Are you able to solve questions? Because many of the students were asking me that if you are not able to solve the questions properly, and you were asking about how to do that. So we have started preparing some videos for you guys also, so that you can just watch those videos and you can get the tricks and tips, really good tips and tricks, so that you can solve questions in short period of time. You can get higher number of marks, and we have started some motivational videos also, so that you may know the importance of clearing these exams, and like JEE and NEET, right? So we'll be moving ahead, and you can just rate your preparation. So I'll be knowing how your preparation is going on. Are we able to help you or not? Are you understanding the videos or not too? You can write that. And that is this, what these emojis mean is actually you can rate your preparation from 1, 2 and 3 level. That is 3 for the happy face. The happy face is that your preparation is really well, and you are really confident in every topic, and you are saying that I'll be able to achieve good ranks. And that one level is that you are underconfident and you are not that confident. You are saying that my preparation is not going that well, and I am lacking in some topics and something like that. So you can write that down too, right? So you can just rate it from 1 to 3. You can write down in the chat. So we'll be interacting and we'll be starting the lecture. Today we'll be starting with Boron family, right? So I have covered Boron family in one of my webinars. We have gone live on YouTube and I have explained about the Boron family. We'll be just revising that part and we'll be moving ahead, because in the last lecture when I started carbon family, many of you guys commented that why are you not just continuing the Boron family. So here I am, and I am continuing the Boron family right now. We'll be continuing with the trends. We'll try to cover the trends as much as possible, right? So we'll be moving ahead without wasting much of the time. So I hope all of you guys have written down your preparation. Okay, young risers, I just want to ask you, what is your real name, so we can interact in the class also, and you can just ask the doubts also. So I'll be introducing myself, then you can also introduce yourself. So actually my name is Khushang Dhingra, and I have cleared JEE few years back, and I am from one of the most prestigious institutes of the country. I have cleared JEE with 99 percentile, and that I cleared that with chemistry. I achieved 99 percentile too. So I have introduced myself. So I just want you guys also to introduce yourselves, and we'll be moving ahead, right? And one more thing I just want to ask, that as I have written that my interest is in artificial intelligence, so you can just also comment down what is your interest in, and what do you guys want, how which stream you want to pursue when you will be clearing GAE and you will be moving on to the your dream colleges, right? So I just want to ask, and you can just write down that too, so we can also discuss that, and I'll be giving you some tips and tricks for that too, and I'll be motivating you, and if you want any type of help from my side, so that we can interact. And obviously we also interact one to one in our courses too. So without wasting much of the time, we'll be starting with our Boron family, continuation of the Boron family. Okay, hi Shresht, how are you? You can just write down how is your preparation going on, and you can also write down. Uh, okay, computer programming, right? So it is a very vast and it is a very good stream if you can pursue that. And for that, I just want to tell you that you need a very, you can say a very decent rank if you want to pursue computer programming in your dream college, right? So computer programming is one of the branches that requires a very high cutoff. So you have to prepare really well. Okay, you have a great interest in Python too. Okay. So Python is also a very good language, and I myself have pursued Python too. So if you want any type of help in any type of subjects in this chemistry subjects besides chemistry in colleges also, you can just comment down and you can just message us also. So I'll be motivating you and I'll be guiding you for that too. So so these things aside, we'll be moving on to the chapter. We'll be focusing on the chapter right now. The chapter is Boron Family. So we'll be moving on. Okay. So where we left was at ionization enthalpy. We were moving on with the trends. So I'll be just revising what we did till now. What we did is we introduced Boron Family. So what is Boron Family? Boron Family was the 13th group. 13th group of P block, right? It was the 13th group of the P block, and I explained you about the trick how to remember that 13th group is, that is bangan, aloo, gajar in heli, right? So it was the 13th group of P block, right? Why we use why we name it as P block? Because of the configurations, what is the configuration? So basically when we write the configuration of all these elements, the last electron enters in the p orbital. So the p orbital, it, as you already know, it has 6 vacant spaces, and we can just put the electrons in these 6 vacant spaces, right? How do we put down? First electron, second electron, third, then fourth, fifth, and then sixth electron. So we have total 6 choices in P block. And when we fill the electrons in the P block, we have total 6 choices. So what does that 6 choices mean? We have 6 different groups of P block. So what is this group? And they are starting from the 13th group, 13th to 18th group, right? So 13th to 18th group in the periodic table belongs to the P block itself, that all of these elements are known as P block. Then I told you about the metal and non-metal and how to differentiate, and I told you about the staircase of the metalloid also. So this boron family is of 13th group. We are starting with all the groups one on one. Then I discussed about the differentiation in atomic radii. When we moved on to the trends, we moved on to atomic radii. So when we compared atomic radii, so I just wanna okay, ns2np, yes, ns2np, and we have the options till 1 to 6. So I just want to ask you one question. What is that question? Is when we move from top to bottom in a group, what does happen to the atomic radii, right? The question is top to bottom, top to bottom in a group. What happens to the atomic radii? Atomic radius, you can say. What happens to it? First option is it increases, second option is it decreases, and the third option is it remains the same, and last option is first increases, first increases then decreases. Okay. So Sharda Devi, you are asking me DTU versus PEC. So I'll be somewhat partial towards DTU because I am from DTU and I have completed my graduation from DTU, so I'll be preferring with DTU. Okay. So Shresht is saying that it increases from top to bottom but not in gallium. So I discussed why not in gallium. You are right, Shresht. So actually what happens is, so you can tell me what is the reason why it not increases in gallium. What is the reason for it? Can you tell me that? So I'll be telling you what was it. It was, okay, gallium is smaller than aluminium. You are correct. I want to know the reason why gallium is smaller than aluminium. Why? The answer to that is, I am expecting an answer from you, Shresh. So, and you also, everyone is watching. You can just write down why gallium is smaller than aluminium. Actually, when we move from top to bottom, the atomic radius or the atomic size increases, right? So, but we have found you can say exception to that. Candide effect. Something, I don't know if this candide effect is another name for that. Actually, the answer is d orbital shielding, right? D orbital shielding. One second. So the answer to that is d orbital shielding, right? Or we can say, or the inert pair effect. Inert pair effect is another name to that. Inert pair. Okay. So we'll be moving ahead. I'll be explaining you what was d orbital shielding. So Shresht, can you tell me what is Scandide effect? It is it another name for d orbital or not? Okay. So what is d orbital actually? So I'll be explaining it to you with an example. Okay. So if I am sitting here and I have a fan, I have a table fan in front of you. If you can see the mic, so you can just consider this mic as a table fan, right? So when a table fan runs, we what we get is we get air from it. So if this, you can say this, you can say this is the mic, this is the filter to it, right? So if I remove this filter and this fan is running, so I can achieve direct air from it, right? Direct air is coming from it. Then I add on a mic, add on a filter to, after the fan, so somewhat some lesser air will be getting on to me, right? And if I build up a complete wall between the fan and me, so no air will be coming on to me. So actually what happens is, the atom, we can draw the structure of atom once and I'll be explaining that. This is the nucleus and all of the electrons revolve around the nucleus, right? They are revolving around the nucleus. One electron here, for example, one electron here, one electron here, and this is a nucleus. So already we guys know that this nucleus contains a positive charge, right? It contains a positive charge, so it attracts the electron. This is a negative charge and it is a positive charge, right? So they both are having an attractive force between them, right? So what actually happens is, we already know that the electrons do not, you can say, fall down into nucleus, right? This is due to the energy in the orbit, which was explained by Bohr. I have explained you that in the chapter atomic structure really well. So what actually happens is, the game is of the orbitals only, right? So that we have studied in the periodic table that s and p orbitals, s and p orbitals have very good shielding, right? Say these both have very good shielding, and we have also studied that d and f orbitals, d and f orbitals, d and f orbitals have very poor shielding. Poor shielding. What does that mean? So you can relate it with the thing I created. I created a wall in front of the fan, right? So you can consider that wall to be s and p orbitals, and you can consider the d and f orbitals to be this filter, right? So they have a very poor shielding effect. What does that mean? That this attractive force to the nucleus, attractive force from the nucleus to the electron, is shielded really well by s and p orbitals. That attractive force is, you can compare it with 0, right? And then comes on to the d orbital shielding. When d orbital comes, actually when we move on from that is aluminium to gallium, d orbital comes in the configuration, right? So when d orbital comes, it has a very poor shielding. So nucleus is having an attractive force on the electron which is comparatively larger than that of the aluminium. Why? Because in aluminium the electron was shielded by s and p orbitals, which are just like a wall. They have a very good shielding. That is, they can shield the force from nucleus on the electron, right? When then comes d and f orbitals, they have a poor shielding. Then more attractive force is applied by the nucleus on the electron. So somewhat some attractive force is still on the electron, so it just comes closer to the nucleus, right? So when it comes closer to the nucleus, due to that attractive force, the size of gallium becomes smaller than that of aluminium. You get it? The size of gallium becomes smaller than aluminium due to d orbital shielding, right? This was the exception, and this d orbital shielding effect, or the Scandide effect, right, which is told by Shresht. So this actually helps in every trend we'll be moving on. It is used in most of the exceptions when we move on to the another trends, right? So we'll be moving on to the ionization enthalpy. So what is ionization enthalpy? Once we'll read that, and I'll be explaining you. The ionization enthalpy values do not decrease smoothly in the when we move down the group. Actually, when we move down the group, ionization enthalpy decreases. Why it decreases? What is ionization enthalpy? We will be moving on to that. What is ionization enthalpy? Actually, it is the energy, or it is the energy we provide in the atom or on to the electron, so that it overcomes the attractive force from the nucleus and it just gets out. We want to extract the outermost electron from the atom itself, right? So if there is an atom, there is one nucleus, the electrons are revolving, there is one electron, it has positive charge, and they both are having somewhat attractive force, and this attractive force acts as a centripetal force, due to which the electron revolves around the nucleus, right? This you guys already know. So somewhat some force is there on the nucleus and it is revolving around. For example, you can just take an example of a ball, and we tie it with a thread, and we just rotate it, revolve it around. The ball will be moving due to the force applied by the hand. It will be acting as a centripetal force, and if we want to extract the ball from the revolving radius, right, we want to pull it, we will be requiring somewhat energy to be applied on that ball, and we'll be removing it from the revolving radius, right? So similar case is there in this atom, and this in this electrons also. We will be providing some energy to the outermost electron, and if that energy overcomes the attractive force by the nucleus, the electron will come out of the atom. It is known as ionization, right? So it is known as ionization, and when we extract the first electron, Pramod Shimpi. Hi Pramod, hi. How are you? uh, we are studying about the ionization enthalpy ones, right? So what I was telling you was, when we provide this energy, we will be extracting the electron. So when we extract the outermost electron, we will be requiring an energy. It is denoted as IE1, that is first ionization enthalpy. We will be writing down first ionization enthalpy, right? So, fine, good. How is your preparation going on? You can just write down in the chat. I have asked with most of the students how is their preparation, and where are you from, you can write that also, so we can interact in the class, right? So it is the first ionization enthalpy. Now we have extracted the outermost electron, we have the outermost electron. Now we want to extract the second outermost electron. You get it? We want to extract this electron. Now this electron is gone, we want to extract this electron. The energy, I want you guys to write if the energy will increase or decrease, if the energy will decrease or if the energy required will increase, what will happen to it, right? The second ionization enthalpy is written as IE2. It is known as the second ionization enthalpy. Okay, Pramod, you are from Mumbai. Okay. You are from Delhi, Manav. I am also from Delhi, guys. So, how are you guys, and how is your preparation going on? Is it going really well? Are you preparing for your dream college? What is your dream college? You can write down. And what is the stream you want to pursue? You can write down also. And if you want any type of help, you can just ask me. I'll guide you also, guys. Okay. So we are basically here so that you can clear JEE really with really good marks, and we can guide you also, you so that you can get a proper guidance how to prepare, which ranks should be you requiring and which ranks are there, so that you can get into your dream college, you can pursue your dream, you can say branch, right? Okay, so you guys can interact too. So first I'll be asking you, you can just focus on the class and you can just make notes. Hi Johita, hi, how are you and where are you from? Okay, so we'll be moving on. We have now extracted the second electron, right? So your dream is IIT and Purdue University. Okay. So from IIT, for IIT you want to just go for JEE Advanced, and you should prepare really well, and you should prepare the topics apart from NCERT too. You already know, I know that you guys already know that, and you should prepare really well for that. You should have a proper sitting, right? You should prepare a sitting for 6 hours at least, because the exam is of 6 hours and you need 2 hours of gap between that. So you just have to prepare that way only, right? So we'll be moving on to the topic. You guys just focus on the topic right now, please. I'll be requesting you, right? So we were moving on to the second ionization energy. For example, you can see here, this is from NCERT even. This is the first ionization enthalpy. For example, in case of boron, we can see the first energy, it is in kilojoule per mole, right? So 801 is the energy required by boron to extract the first electron. Then we require 2427 kilojoules per mole of energy to extract the second electron, right? So you can see the energy has increased to another extent. Why is it so? Why? Because the next electron is in the inner shell and it has a large force from the nucleus, and we want to overcome that force so that we can extract the second outermost electron, right? So these energies increase when we move on to the first ionization, second ionization, third ionization. So this is a very important thing, and this was the question asked in JEE 2, right? So actually when we move on, now we'll be moving on to the elements, right? We are talking about the 13th group. So when we move in the 13th group from top to bottom and we move in any group from top to bottom, the general trend is that the ionization energy decreases from top to bottom. Why is it so? If any one of you can write down in that chat too. Why the ionization energy decreases when we move from top to bottom in a group, right? You can just write down in the chat. I'll be erasing this and I'll be writing why is it so, right? So you guys can just write down. So where are you from? Delhi. So I am from Delhi, and that's it guys, that's it. I am from Delhi, right? Where are you from? You can tell me that. Juhita, you are saying that you are preparing for JEE mains or advanced. What is your current target? If you want to go for NITs, DTU, NSIT, these are the target should be JEE mains. If you want to target for IIT, then your target should be JEE advanced straight, right? So you should have targets clear in your mind, right? So okay, so now I'll be writing why. None of you guys have written why the ionization energy decreases from top to bottom. Can you? Okay, I'll be writing the answer. The answer to that is the size of the atoms. Why does size differentiate? Oh, sir. Okay, no problem. Okay. So there are some rules and regulations. I hope you understand, right? So when we move from top to bottom, the size increases. Size of the element increases, right? So the outermost electron is getting far away as we move from top to bottom in a periodic table. It is very obvious. ऊपर से नीचे जब हम जा रहे हैं, जब हम ऊपर से नीचे जा रहे हैं, साइज बड़ा हो रहा है, इलेक्ट्रॉन दूर हो रहा है, राइट? इलेक्ट्रॉन इज गेटिंग फार्दर अवे, राइट? So sir, cause the size increases from down the group, right? Electron is getting farther away. The attractive force, what is the attractive force? Formula for attractive force between two charges, K Q1 Q2 by R square, right? So R, this radius is increasing and force is decreasing by its square. So obviously lesser energy will be required to pull out the outermost electron, right? So similar is the case, but you can see 801, 597, 579, 558 and 589, right? This trend is really gross. Here everything is going really gross. Why is it so? This is also due to the d orbital shield. In most of the cases in the 13th group, the answer will be d orbital shielding, right? So the answer will be d orbital shielding, right? So let us read what here is written is that variation can be explained on the basis of poor screening effect of d and f orbital. D and F orbitals are having poor shielding effect. When there will be poor shielding effect, more force will be there on the electron, and the harder will be harder we will require, the more energy we will be requiring to put on in that element to extract the electron. I hope all of you guys get it. If yes, then you can write down in the chat. Okay, then we'll be moving on to the density. After density, I'll be explaining you about electronegativity too, right? So we will be moving on to density right now. Right? So when we move from top to bottom, what happens to the density? I just want to ask you what happens to the density when we move from top to bottom. Answer to the problem is that density increases down the group. Density increases down the group. Why? Because density is what? Density is mass divided by volume. Right? Density is mass divided by volume. What is the volume of atom? What is the formula for volume of atom? Actually, atom is a sphere, so volume will be 4 by 3 pi r cube. So when and the mass, main thing is mass. So you can see that radius is not increasing to that extent that volume, when the volume increases, then the volume increases to such a very big extent. And mass, you guys already know the atomic mass is how the mass is increased with a very great extent, right? So that is the reason that density increases down the group. So I'll be writing the densities of all the elements quickly, right? What is the 13th group? Bangan, Alu, Gajar, in, Heli, right? Densities to that is, I'll be using a different pen, that is 2.35, then 2.70, then 5.90, and then 7.31, and then 11.85. What is the exception here? Density is increasing down the group. What is the exception here? You see here. Highlight it. This is the exception. What is this exception? Actually, this exception is that there is a very large jump from aluminium to gallium. Why is it so? Why there is such a large jump from aluminium to gallium? So Manav, can you write the reason why there is such a large jump? Almost double, greater than double even. You can see if we multiply 2.7 to 2, it will be 5.4. 14 2, yes, it will be 5.4. So what is the reason that the density has jumped to greater than double from when we move from aluminium to gallium? What is the answer to the question? Answer to the question is again the orbital shielding. Again the answer is the orbital shielding. How? Actually, we have seen that atomic radius we have seen. When we move from aluminium to gallium, the atomic, you can say, what is density? Density is mass by volume, right? The volume increase from aluminium to gallium will be very less. Why? Because the radius of gallium is smaller than that of aluminium. Why? Due to d orbital shielding. I have told you that. And volume will increase by a lower quantity and mass will increase by a larger quantity. When the denominator is small and the numerator is large, the quantity will be really large even. So this is the reason, because so that the gallium's density is more than twice than that of aluminium, right? So answer to that problem is d orbital shielding. Now d orbital make a shielding layer, not a shielding layer in this case. In this case, there is a simple mathematics that density is mass by volume. Volume is equal to 4 by 3 pi r cube. Radius of gallium is smaller than that of aluminium, right? So volume will be less. Mass has increased to a very large extent, right? When we move from top to bottom, the mass of gallium is really large than that of aluminium. So this is the reason that density of gallium is increases more than twice than that of aluminium, right? So this was the reason. Now we'll be moving on to the next trend, that is electronegativity. These are electronegativities of all the atom. Electronegativity decreases down the group. First decreases from this boron to aluminium, then it increases. Why is this? Why is this? Because of the differences in atomic size of elements, right? Because of the differences. First thing, this boron is a non-metal, or it shows some properties of metalloid too, right? And these all are metals, right? These all are metals. Metal are having you can say lesser electronegativity than that of non-metals. Non-metals are bad, metals are good. Metals have a tendency to give electron. It is the you can say the characteristic of metallic elements, metallic property. See, so this is a non-metal, so it has a very huge electronegativity, and here we can see that electronegativity increases when we move from top to bottom, right? It is really simple, and the size of this helium is really large, so it has larger electronegativity than that of aluminium, gallium, indium and thallium, right? The next trend we'll be moving on is the melting and boiling points. Melting and boiling points. I'll be writing down, I'll be taking a, you can say, blank page. I'll be writing down the melting and boiling points. Okay, so I just want to ask you, what does happen to the melting and boiling point when we move from top to bottom, right? Melting and boiling point from top to bottom. What is the meaning of melting point? That how much heat should be given so that it melts. And what is boiling point? How much energy or how much heat should be given so that it boils. So what should happen to melting and boiling point when we move from top to bottom? I am waiting for your answers in the chat, and I'll be writing the answer very soon. Right? So, okay. Answer to this problem is that melting point and boiling point decreases when we move from top to bottom. Why? Why is the question again? Why is the question? The question is why melting and boiling point decreases when we move from top to bottom. Hi Harsh, how are you? How is your preparation going on? Okay, Manav, the question is that why the melting and boiling point decreases when we move from top to bottom. First, just tell me the answer, and I'm waiting for answer from till 5 seconds, and I'll be writing the answer. Right? So why the melting and boiling point decreases when we move from top to bottom in the group? Because the answer is because size and bond length increases when we move from top to bottom. Because size and bond length increases when we move from, because the interaction force between your answer is incomplete, Manav. You should complete your answer first. What is boom boom? You can also tell me what is boom boom. Size and bond length increase when we move from top to bottom. Okay, so when what is actually melting and boiling point? When we want to melt something, we want to break the bonds between it. We want to break the bonds between it, and we want to we should provide somewhat energy to break the bonds, right? So if the bond length is larger, it is having a lesser strength in it, right? So we will give lesser amount of energy to break those bonds, right? And it will melt down. Same is the case with boiling points, right? So when we move from top to bottom, the size increases, the bond length also increases and the melting and boiling points decreases. We want lesser energy to boil and melt the elements when we move from top to bottom. Okay, right. No problem, no problem, no problem. No need to say sorry. It is just a technical error, I know. Okay, so we'll be moving on uh, to the next characteristic or the next trend. Okay, so we will be moving on to the somewhat physical properties of all the elements. So I just want you guys to open your notebooks and you just write down the properties. So these are very really important for your JEE, and they are asked directly. They come directly from NCRT, right? So boron is a hard black colored metal. Why is there is a high melting point? Because the boron has a crystalline structure. Crystalline structure of boron. And what is the name of the structure of boron? What is the name of structure of boron? Right, the name is icosahedron. Icosahedron structure. Icosahedron structure. What is the spelling? ICOSA hedron structure. This is the structure of boron, right? Uh, no problem, Manav. Just ignore those elements and you can just focus on the class, right? So icosahedron structure, the boron exists in icosahedron structure. It has 20 different atoms of boron at once. So it has a really well crystalline structure. So we require a larger amount of energy, so larger amount of boiling point and melting point to melt and boil boron, right? So this is the reason, and you can just write down this icosahedral structure. The question was asked in JEE Advanced, and I have just noted down and I am giving it to you guys, and you can just note down, and it is really important, right? So the boron is hard and black colored. Others are soft metals and low melting points, and they are having high electrical conductivity. Why high electrical conductivity is there? Because all of them are metals. Boron is a non-metal, right? So density of the elements increase down the group, as I have already told you. Gallium, it is a useful material for measuring high temperatures, as it has a very low melting point and very high boiling point. Even in summers, gallium exists as liquid. It has such a low melting point. Why is that? Because when we saw the structure of gallium, what we found is that gallium exists not as a metal, it exists as a structure like this, as a bimolecular, or you can say yes, a bimolecular structure, right? So it exists like this. Two atoms are connected like this only. So it has such a low melting point that it exists as liquid in summers, right? So I hope all of you have got what I have told you in class, right? We'll be just ending up the class right now, so time is up. So first of all, I just wanna tell you first thing that about our course, how you can join the full course, right? What is the course? let me explain you about the course. Course is about, we provide you PDF materials, we provide you classes, and you can just join the Telegram channel. You can just scan this QR code and you can join the Telegram channel, and you can just where we provide PDF materials. Also we provide announcement for our free classes which will be going on YouTube, like you are watching right now, 1 2, and we'll be announcing some discounts and prices on that too. And one surprise for you, uh, today also I'll be giving it to you in the somewhat 1 to 2 slides after that. And we provide free classes regularly, and you can just subscribe to our YouTube channel, and regularly we do these webinars like I'm doing it to you with right now. And we'll be moving on, and I can just explain you about my course. What is my course even? I'll be giving it to you, and we'll be interacting live in here 90 plus classes. I am telling you, we'll be interacting more than 100 classes even, and I'll be solving your doubts in each and every subject. There is a very conventional and convenient educational platform is this. We have syllabus from JEE experts, and we use a classroom method known as flipped classroom method. What is the flipped classroom method? It is really important, and the top end universities like Harvard also use this flipped classroom method. What is actually the flipped classroom method? We provide you the materials before the class, and so that you can read the materials and then you can attend the class. And then after the class we'll be providing you homeworks where you can solve the questions. We'll be checking your homeworks, we'll be providing you the topics where you are lacking, right? And then we'll be giving the doubt solving practice to you as well, right? So how our classes look like, this is actually the diagram of uh, flipped classroom method. We'll provide you theory, then study materials, then we'll be having a webinar, then we'll be giving you homeworks, and then we'll be getting your homework checked, right? So this is a very effective program. Then we are having three types of classes. See, three types of programs. I know every student is different, and every student has different requirements, right? So Manav, I'll be explaining it to you, as you were studying really well with my class. So what is actually, here I have just given you half an hour, or you can say 40 minutes lecture on Boron family. If you have connected with me, right? If you are interested in getting education, and if you are getting interested in the coaching we are providing for JEE, in the guidance we provide, so we have three types of plans. They are really economical, and if you can just wait for 2 minutes, I'll be giving a really good surprise to you. What is that? We have three plans, that is light plan, smart plan, and proficient plan. What is there in the light plan? We'll be interacting live, right? We'll be giving you PDFs and study material, we'll be having live tests, and physical notes we'll be providing you. And in the smart plan, we'll be having extra is that we'll be having live doubt solving, one-to-one mentorship. I'll be interacting with you, and I'll be guiding you in any type of problem you are getting, and type of colleges, uh, discounts, every problem you can discuss with me. Even if a single doubt, you can message me on WhatsApp, I'll be solving that doubt and providing the solution to you. And the most important thing is mock test. Mock tests are really important. This is the main thing which due to why I am suggesting you can take the smart course, and you can get the mock test, because mock test will help you really well to increase your marks, because it provides you a real time experience of giving the exam, right? And this proficient course is for those students who want to prepare for advanced, right? They are if they want to prepare for advanced, so we'll be providing some advanced classes, some advanced topics we'll be explaining you. We'll be preparing for JEE advanced really well, and we'll be leaving no stone unturned. Every topic will be covered in the proficient course, and every topic will be covered in the smart course even. And but in the proficient course, some topics which are asked in the JEE advanced only, we'll be providing you that. Okay, so main thing is, this was the surprise I was talking you about. So for 1 month you can take the course, which is of 3300. I'll be providing it to you with 299 only. What you have to do, you have to use this promo code. What is the promo code? I am giving you my promo code. You can just put that promo code and you will be getting the course with 299 rupees only. It is really cheap. I think you guys already know that, right? The promo code is JEE Chem 30. This is the promo code, and you can just write this promo code and you will be getting the course in 299 rupees only, right? So this was it, dude. Come on. Okay, no problem. And these are for you can just join the Telegram channel. Here we chat. You can chat with the aspirants and faculties. I myself have joined this group also, and these are for useful files. Here are some PDFs and announcements also. You can just take the screenshots, scan these QR codes, and you will be getting joined to that group. This is our Instagram, that is Altedemy. This is our Telegram channel, Alt J. You can join that. Many students in number of in thousands of students have already joined. You can just go there and check. There are many students. You can check that and you can interact with us guys also. Okay, so this was it for today, guys. So I'll be seeing you soon in the next lecture, and if you will be taking that course, I'll be seeing you there. We'll be interacting live and we will be having a lot more discussions about that too. So see you soon. Bye guys.